Hi students, how are you all? I hope you all are remaining safe and you all are healthy, right? So in the previous session what we discussed was regarding speed, velocity, distance, displacement, and students, I must remind you that whenever a body moves along a straight path, then the distance of the body covered is equal to its displacement, right? And if distance is equal to displacement, then the speed of the body must be equal to its velocity. So in case we consider one-dimensional motion where the body moves along a straight path, then either you can make use of the term speed or velocity. Either you can make use of the term distance or displacement, because in one-dimensional motion, when the body moves along a straight path, distance covered by a body would be equal to its displacement, and accordingly speed of the body would be equal to its velocity, right? So in this session we will be discussing the method, or rather the formulas to calculate average speed or average velocity in various cases, right? So these are the two cases which we will be discussing. Body covering equal displacements in unequal intervals of time, right? Body is covering equal displacements but unequal intervals of time, and the vice versa case. That is, in the second case we will discuss the formula to calculate the average speed or average velocity for those bodies which are covering unequal displacements in equal intervals of time. Here it is equal displacements in unequal intervals of time, and in the second scenario we will discuss bodies covering unequal displacements in equal intervals of time. So let's start with the mathematical aspect, right? Let's assume some body which is moving along a straight path. I mean, we are dealing with one-dimensional motion. So this is it. Suppose a body starts from point A and reaches point B, and let us consider this to be the midpoint, point C. Point C is the midpoint. So if the total distance is 2x, then this distance would be x and this distance would be equal to x, right? So here we are dealing with equal displacement in unequal intervals of time, right? So these are the two equal displacements or two equal distances covered by the body, two equal parts. Suppose the body covers this first part, AC, with speed v1, and the same body covers CV with speed v2. In covering the distance from A to C, suppose it takes time t1, and in covering another equal distance, that is C to B, suppose it takes time t2. So what we have considered is time interval in covering these equal displacements are different, right? So we need to find out the average velocity for the trip of the body from point A to point B. Now as you are aware, average speed is equal to the total path length divided by the total time taken. Average velocity, it will be equal to the total displacement divided by total time taken. So we will make use of this formula. So let's find average speed. Average speed would be total path length divided by total time. So total path length, we are considering this to be initial point and B to be the final point. The total distance covered by the body from A to B, it would be x plus x, that is 2x. Total time taken, this is time t1, this is time t2. So total time which the body takes in covering the distance from A to B would be t1 plus t2. Am I clear? Now suppose we need to express the average speed in terms of v1 and v2. So what to do is, you are aware of this basic formula, distance is equal to speed into time. That is, time may be written as distance divided by speed, isn't it? We can write it like this. So what we get is 2x t1 is the time taken by the body to move from A to C. So what is the distance from A to C? It is x. And with what speed the body is covering this distance? v1. Similarly, time t2, distance over speed. This is the distance covered with speed v2. So it will be x over v2. We can easily solve it. So what do you get is 2x over here, LCM would be v1, v2. And here we get x as common. So we'll get v2 plus v1. So on solving, what do you get? X's get cancelled, right? So v1, v2, it will become the reciprocal of this. So twice v1, v2 divided by v1 plus v2. So average speed is equal to twice v1, v2 divided by v1 plus v2. This is the formula which you can use directly in solving the average speed of a body when the body covers equal displacements in unequal intervals of time. That is what we have discussed over here. And students will discuss some special case as well, right? Before that, I must again remind you, in this case the body is moving along a straight path, isn't it? Body is moving along a straight path. So here, average speed would be definitely equal to average velocity. Each would be equal to twice v1, v2 divided by v1 plus v2. So please keep this in mind. In case the body moves along a straight path, then the length of the path covered, that is distance of the body, would be equal to its displacement, and accordingly the speed of the body would be equal to its velocity. So in case the body moves along a straight path and it covers equal displacements in unequal intervals of time, then this is the formula which you can make use of directly so as to find out the average speed or average velocity. Twice v1, v2 divided by v1 plus v2. Right? No need to know the distance or no need to know the time. Only in terms of v1, v2 you can easily get the answer. This is actually known as the harmonic mean. If two numbers a and b are given, if two numbers a and b are given, then their harmonic mean is given by twice AB divided by A plus B. This is actually the harmonic mean of two numbers A and B. So here, if the two numerical values are V1 and V2, then the harmonic mean would be twice V1, V2 divided by V1 plus V2. So that's an important conclusion. So what I mean to say is that whenever the body covers equal displacements in unequal intervals of time, then the average speed or the average velocity of the body is given by the harmonic mean of the individual speeds, of the speeds V1 and V2. So this is the harmonic mean of V1 and V2. You can remember in that way, right? Now before we proceed to the next case, let's discuss some special cases, right? Let's discuss some special cases. So what we do is, we'll consider same case, body covering equal displacements in equal intervals of time, but let's consider a different scenario. Now what to do is, let us consider a body to be moving from A to B. Let us consider a body to be moving from A to B and then coming back from B to A and then coming back from B to A. So let's see. What will be the situation in that case? What will be the average speed and average velocity of the body in this case? So again I am repeating. This is a special case, right? So what we are considering is a body starts from point A, reaches point B, say with speed v1, and then again comes back from B to point A, say with speed v2. So what will be the average speed or average velocity throughout the journey, right? Obviously, it is covering equal displacement. Suppose the distance from A to B is considered to be, let us consider to be x. Let AB be the distance which is given to be x. x to x, it's your wish, whatever, right? So in such a case, or you can write as 2x as well, it's your wish. So it is covering equal displacements, A to B, it is covering distance x. B to A, again it is covering distance x. Right? With different speeds, so obviously it will take different time. Suppose it goes from A to B taking time t1, comes back from B to A taking time t2. So again, we are dealing with the same case. The body covering equal distances in unequal intervals of time. Right? So throughout the journey, what will be the displacement? It will be equal to 0. Students, you must remember, whenever the initial position coincides with the final position, the displacement is always 0. So here, displacement 0. Initial point is A, and again from point A it is again coming back to point A. So initial and final position coincides, so displacement is 0. And whenever displacement is 0, the velocity would be 0. So here in this case, average velocity would be 0. Right? While on the other hand, average speed, it will be given by the same formula as was discussed earlier. Since it is covering equal displacements, equal distances in equal intervals of time, therefore it will be given by harmonic mean of V1 and V2. Twice V1, V2 divided by V1 plus V2. So this is a very important concept which you should keep in your mind while doing numericals based on this. So what we have done was, if a body moves along a straight path covering equal distance in unequal intervals of time, then the average speed would be equal to average velocity. Each would be given by twice V1, V2 divided by V1 plus V2, which is the harmonic mean of V1 and V2. Right? In case the body moves from point A to B and again comes back from B to A, here also it is covering equal distances in unequal intervals of time. Here, the average velocity would be 0. Average speed, as we are aware, it will be given by harmonic mean of V1 and V2, which is twice V1, V2 divided by V1 plus V2. Is it clear? So, do remember this concept, right? We can consider another special case as well. Let's consider special case 2. What to do is, again, a body starts from point A. Let us assume the body starts from point A. The body starts from point A and after covering 3 equal parts, 3. Suppose this is B, this is C and this is D. All are equal. So suppose it covers 3 equal parts in different intervals of time. Right? So it covers this distance with speed V1 and takes time T1. It covers this distance B to C with speed V2 and it takes time T2. And in covering the distance C to D, it is moving with speed V3 and it takes time T3. And these are all equal distances. Right? Suppose X. So obviously, again, body moving along the same straight path. Right? It is not returning back. So over here, the distance would be equal to displacement. So therefore, average speed would be equal to average velocity. Obviously, in this case, average speed, it would be equal to average velocity. It is equal to total path length divided by total time taken. What is the total path length? Total path length. It would be equal to x plus x plus x, that is 3x. Divided by what would be the total time taken? Total time taken in order to cover this distance 3x, that is t1 plus t2 plus t3, right? So let's substitute the values of t1, t2, t3 and get the result in terms of v1, v2 and v3 only, right? So what we get is 3x divided by t. What's the relation between distance, speed and time? Time is distance over speed. So t1 it will be equal to distance x by speed v1, that is x by v1. What about t2? Again, distance covered divided by speed v2, x by v2. What about t3? It is distance x divided by speed v3, that is x by v3. So again, you can consider LCM. So over here, LCM would be v1, v2, v3, right? v1, v2, v3, this will be the LCM. X can be taken as common. Here we will be left with V2 V3 plus V2 is common, so we'll be left with V1 V3 plus V3. So here x is already taken as common, so here we'll be left with V1 V2. Right? X get cancelled. It's a case of division, so in case we convert it into multiplication, it will become reciprocal. So what we get is 3 V1 V2 V3 divided by V1 V2 plus V2 V3 plus V3 V1. This is the formula to be used when a body covers 3 equal parts in unequal intervals of time. So students, while solving numericals, especially in case of MCQs, you can directly make use of these formulas so as to save time, right? So, when a body moves along a straight path, not returning back, moves along a straight path, then always remember, the average speed of the body would be always equal to its average velocity. In case it returns back to its original position, that average velocity throughout the journey would be 0, right? In case of 2 equal parts, the average speed is given by twice V1 V2 divided by V1 plus V2. And in case of 3 equal parts covered in different intervals of time, then the formula becomes thrice V1 V2 V3 divided by V1 V2 plus V2 V3 plus V3 V1. So do remember these formulas, especially for MCQs, right? Okay, so case 1 is over. Let's proceed to the second case. Now what we'll consider is body covering unequal displacements in equal intervals of time. So there also we need to find out the result in terms of V1 V2. We'll try to find the result in terms of V1 V2. So let's try to solve it. Remember, in the previous case we have considered body to be covering equal displacements in unequal intervals of time. Here our intention is to find out the formula for the average speed when the body covers unequal displacements in equal intervals of time, right? So this is the scenario basically. This is A, this is B. Let us consider this to be C. These are the unequal displacements, right? So suppose this is distance x1. Let us consider this to be distance x2, right? This distance is covered with time t. This distance is also covered with time t. Equal intervals of time. So the body is covering unequal displacements in equal intervals of time. So here, suppose it possesses speed v1 and here it possesses speed v2. Now make use of your common sense. Obviously, in the same time, in this case the body is covering larger distance. So its speed would be greater than that of this one, isn't it? Anyway, coming back. Here, average speed would be equal to average velocity. Why? Because the body is moving along a straight path. Distance is equal to displacement. Therefore, average speed would be equal to average velocity. Total path length from A to B. What is the total path length? That is x1 plus x2 divided by total time. Speed or velocities. Total path length divided by total time taken. So x1 by x2 is the total path length divided by total time is t plus t. That is x1 plus x2 divided by twice t. Now, distance x1, its speed into time. So x1 is equal to v1 into t. Similarly, x2 is equal to v2 into t divided by 2t. T is common. So what do you get? v1 plus v2 divided by 2. Students, this is actually the arithmetic mean. It's the average value. So remember, whenever the body covers unequal displacements in equal intervals of time, then the average speed would be given by the arithmetic mean of the speeds, v1 and v2. Right? This is the arithmetic mean. Sum of all the observations divided by total number of observations. Right? So this is given by the arithmetic mean of v1 and v2. In the previous case, where the body covers equal displacements in unequal intervals of time, there the average speed is given by the harmonic mean, which is twice v1 v2 divided by v1 plus v2. So we can deal with a special case as well. in case it is covering three unequal parts in equal intervals of time. Suppose this is A, this is B, this is C, and let us consider this to be D. All are unequal parts. This is x1, this is x2, and this is x3, right? All the distances are covered, all the unequal distances are covered in equal intervals of time. Over here, suppose the speed is v1, here v2, and here v3. So in this case, again, since the body is moving along the straight path, the average speed of the body would be equal to its average velocity. Each would be equal to total path length, that is x1 plus x2 plus x3, divided by total time taken, t plus t plus t, that is 3t. So x1, this distance is equal to speed into time, so it may be written as v1t. Similarly, x2 may be written as speed into time, that is v2t. x3 it is v3 into t, divided by 3t. T can be taken as common, so we will be left with v1 plus v2 plus v3 divided by 3. Look, sum of all the observations divided by total number of observations. So whether the body covers 2 unequal parts, 3 unequal parts, or 4 unequal parts, the average speed or velocity is given by the arithmetic mean of v1, v2, v3, v4 and so on. Arithmetic mean. It is the sum of all the observations divided by total number of observations. Right? Before proceeding, we can start with some basic questions. We can start with some very basic questions. Right? Suppose, students, please listen to the question very carefully. Suppose a person starts from his home and goes to a market with a speed of maybe 40 km per hour, and finding the market closed, he comes back to his home at a speed of 60 km per hour. Right? Again I am repeating. Let us consider a person who goes from his home to market with a speed of 40 km per hour, and finding the market closed, he comes back to his home with a speed of 60 km per hour. This is home and this is market. So this is suppose A, this is B. He goes from A to B with speed of 40 km per hour and comes back from the market to home with a speed of 60 km per hour. Right? So, what will be the average speed and average velocity of the person throughout the journey? So first, identify the quotient, which formula is to be used. Now the body is covering equal distances. A to B is equal to B to A. Right? So it is covering equal distances. So whenever the body covers equal distances, the average speed is given by the harmonic mean. So here the average speed will be given by, we have already proved the formulas, right? So here while solving numerical, I can make use of the formula directly, right? So the average mean in this case will be given by the harmonic mean of these two values, v1, v2. So it is twice v1, v2 divided by v1 plus v2. So it will give us twice into 40 into 60 divided by 40 plus 60. So it will be further twice into 40 into 60 divided by 100. So 48 km per hour. Is it clear? So in this case the average speed is 48 km per hour. What about the average velocity? Come on, what about the average velocity? Yes, it will be 0. Why? Because the body is coming back to its original position. So displacement 0, the average velocity would be also 0. So average velocity in this case would be 0. Clear? So while dealing with such questions, first identify which case does the numerical belong to, and accordingly you need to apply